In 2020, the European Food Safety Authority, otherwise known as EFSA, identified a need for the development of a roadmap for action on the risk assessment of combined exposure to multiple chemicals, or RACEMiC for short. This presentation will provide you with an overview of the RACEMiC project, in which this roadmap was developed by a consortium of 4 partners, namely the Dutch National Institute for Public Health and the Environment, Biometrische Wageningen University and Research, the German Federal Institute for Risk Assessment, and the Technical University of Denmark. So, why do we need a roadmap on mixture risk assessment? Current practice in the risk assessment of chemicals mainly relies on the assessment of individual chemicals, each within their own separate legislative framework, such as regards pesticides and contaminants. However, in real life, we're not exposed to single chemicals. Instead, we're exposed to a wide variety of chemicals at the same time. There's a growing concern in society regarding this combined exposure to multiple chemicals. Despite these concerns, only pesticide legislation specifically includes requirements for mixture risk assessment. However, the Chemical Strategy for Sustainability has emphasized the need to address risk assessment of both intentional and unintentional mixtures in European regulations. Within EFSA's domain of activity, it specifically calls for such approaches for food additives and food contact materials. To meet these policy goals, EFSA aims to be ready for the routine implementation of human health risk assessment in relation to multiple chemicals across its domain of activity by 2030. This will require the development of harmonized tools and consolidated data on both dietary and non-dietary exposure to multiple chemicals. But how do we move from the current practice of substance-by-substance evaluation towards a future of mixture risk assessment, not just within regulatory domains, but also across chemical domains? What methods, data and tools need to be generated to allow for this change? It's precisely this question that the RACEMiC roadmap is intended to answer. The aim of the roadmap is to help EFSA achieve its goal of routine implementation of human health risk assessment in relation to multiple chemicals. The roadmap describes the methods, data and tools that are already available and have been developed in EU-funded projects such as the EuroMix project, the HBM4 Human Biomonitoring Initiative and the Athlete Exposum project. It further identifies current scientific gaps that might still be present in order to move from substance-by-substance evaluation towards mixture risk assessment, both on the hazard and exposure sides. Furthermore, links were identified between these scientific gaps and ongoing projects, such as defined in the European Partnership for the Assessment of Risks from Chemicals, PARC, and project proposals were developed for key scientific gaps not already addressed in other projects. A series of steps were taken to develop the roadmap. The first activity of the project was to identify the scientific gaps which are currently hampering the implementation of mixture risk assessment, or MRA for short, as well as identifying the challenges and blockages associated with filling these data gaps. To identify these scientific gaps, we first conducted a mapping activity to create an overview of the methods, data and tools that were available for MRA in 2021. We did this by conducting desk research, looking at publications from scientific journals and EFSA publications, and looking into the plans of relevant research projects that are currently ongoing. In addition to the scientific overview, we gathered stakeholder input on the subject by conducting a survey. The aim of this survey was to identify any methods, data or tools that we might have missed in the desk research part of the project. The scientific gaps were identified based on the overview of the current practices in MRA. Thereafter, project proposals were created that aimed at filling key data and knowledge gaps in MRA. To further refine these project proposals, we organised meetings with stakeholders through online targeted discussions, as well as a stakeholder workshop. In these discussions with stakeholders, we asked for their input on the priority of the different projects, as well as suggestions to further improve the proposals. Their feedback led to the final project proposals as reported in the roadmap. To achieve the aim of routine implementation of MRA, it will be important that different stakeholders work together to generate the methods, data and tools. In order to identify engagement opportunities, a survey was therefore conducted among stakeholders, establishing their needs. In addition, a questionnaire was sent to communication experts at national food and nutrition centres and national public health institutes in Europe, so as to identify opportunities for communicating about MRA to the general public. In developing the roadmap, we focused the mapping activity on 5 areas. 4 were chemical-specific areas within EFSA's domain of work, including pesticides, food contact materials, contaminants, and food additives. Furthermore, we also focused on horizontal chemical domain overarching methods, data and tools, as the ultimate goal is to move to cross-silo risk assessment. The idea is that methods, data and tools that are developed within the chemical domain can also be used in the horizontal methods. In the roadmap, we created an overview of the current state of play for combined risk assessment in relation to multiple chemicals within different chemical domains, as well as for cross-silo mixture risk assessment, MRA. As expected, the readiness for MRA in the field of pesticides was quite high, particularly in the case of dietary exposure. A lot of work has already been done and methods are in place for both retrospective as well as prospective cumulative dietary risk assessments. In the case of food additives, the readiness level was also considered relatively high, as sufficient hazard information for grouping is available for most food additives, and as occurrence exposure data are, to a certain extent, available on which MRA could be conducted. In the case of certain contaminants, such as dioxins and per- and polyfluorinated substances, or PFAS, the readiness for MRA is also high, as sufficient data on both hazard and exposure are available. However, MRA is mainly limited to contaminants from predefined groups of chemicals that are structurally closely related. More data would be needed to assess all contaminants. With regard to food contact materials, FCMs, the availability of methods, data and tools for MRA were quite limited. The hazard data needed for grouping is missing for a lot of food contact materials. Similarly, on the exposure side, there is occurrence data for certain specific food contact materials, but not for most of the substances. In the mapping activity, a limited number of examples could be found in which cross-silo MRA was attempted. Some examples included human biomonitoring studies and the Athlete project, in which an overarching exposure assessment was performed. This included several classes of chemical affecting IQ loss. Overall, the readiness for cross-silo MRA was concluded to be low. Based on the overview of the methods, data and tools, we identified in each chemical domain which pieces of the puzzle were still missing, whose inclusion would allow for a mixture risk assessment. As indicated before, methods, data and tools are available for dietary MRA for pesticides. However, methods and tools need to be developed for non-dietary risk assessment. Moreover, the current risk assessment of plant production product focuses on the active substance, and therefore data addressing the influence of co-formulants is needed. Regarding contaminants, the availability of methods, data and tools for MRA was high for certain contaminants. However, for other contaminants there was a general lack of data on both hazard and exposure, which would need to be generated to allow for MRA. Similarly, in regard to food contact materials, FCMs, there's a general lack of both hazard and exposure data for a lot of FCMs. The key scientific gaps identified included a lack of hazard data on which grouping can be done, the limited availability of exposure data for most FCMs, and a lack of criteria for prioritization. For food additives, the key identified scientific gaps included the lack of criteria for prioritisation, a lack of hazard data for some food additives, the need to define assessment groups and scenarios for MRA, and the lack of computational tools for the MRA of food additives. Some improvements here would be to broaden the Open Food Tox database to aid the grouping, to create a database with exposure and more harmonised monitoring of analytical use values, and the harmonised collection of label data. So, now that we've identified the key scientific gaps, the question arises, how do we fill in these missing pieces of the puzzle? We looked at the scientific gaps to see what elements might be filled in over the short term and what would require more longer-term plans. In the short term, the focus should be on filling in the data gaps within chemicals domains and trying to complete the puzzle there. The reason for this being that the methods, data and tools generated within the selected chemicals domains can then be used in the cross-silo MRA. For example, if we don't have sufficient hazard data to create assessment groups within a chemical domain, this will also translate into an issue for cross-silo MRA. As part of this project, we put forward a set of project proposals aimed at generating the methods, data and tools for MRA, which could be of relevance to EFSA's future work. These were split into projects that would be conducted in the short term, mid-term and longer term. These proposals are recommendations on which EFSA might base future calls for tender around the topic of MRA. Synergies with projects granted by the European Commission were identified, which may also generate data and methods for MRA. For example, data generated in the PARC project feeds into the project proposal on the human biomonitoring in MRA and into the work being conducted in the Framework Partnership Agreement between EFSA and the RIVM on the Monte Carlo Risk Assessment Model, and has a link with the project proposal on a cross-framework MRA tool. We'll go through the individual project proposals in a bit more detail in the next slides. In the end, it'll be up to EFSA to identify the projects they wish to work on. 5 proposed projects were defined as short-term. The first was a project aimed at developing a methodology for the non-dietary MRA of pesticides. It consists of gathering information on which type of combined use of pesticides occurs in the field, as well as developing an exposure model which is suited for MRA. Regarding food contact materials, FCMs, it's proposed to first conduct a pilot study because, as indicated previously, the readiness for MRA in this chemical domain is still quite low, and a lot of methods and data still need to be developed. A pilot study will allow for the identification of data gaps and other issues that may come up in developing the methodologies, without having already assessed a wide range of FCM substances. The pilot study would focus on developing general methodology for MRA, establishing a prioritisation strategy to determine which FCMs should be concentrated on, and on how to generate data on the actual mixture exposure to FCM that takes place. 2 short-term projects were identified concerning contaminants. One project proposal focuses on establishing a prioritisation strategy and on developing and applying grouping strategies for the prioritised substances. The second project proposal is a first step in a bigger project to establish relative potency factors, in short RPFs, for contaminants. And that first step is to organise expert discussions on how to establish RPFs for contaminant groups using existing data. A next step in this project, which we put more in the mid-term, is to generate additional data to derive RPFs for contaminants where data is currently lacking. A pilot case study was proposed for food additives, focusing on the development of methodology for MRA, such as a prioritisation strategy, a grouping strategy, and an exposure scenario tool for MRA. For the mid-term, the roadmap proposes 3 chemical domain overarching and cross-silo projects. The first would develop cross-silo MRA methods, including building functionalities for cross-framework MRA into an open toolbox such as MCRA. From an animal welfare and a practical point of view, it's not desirable that these hazard data gaps be filled using animal testing. Therefore, a project was proposed focusing on the use of quantitative structure-activity relationship, or QSAR, to fill these data gaps by developing a comprehensive repository of QSAR predictions to support grouping both within as well as across chemical domains. The final proposal is to develop a cross-silo method for MRA of the combined risk of contaminants in food additives and other food ingredients. Another midterm project is to combine the non-dietary exposure with the dietary MRA methodology once the methodology for non-dietary MRA relating to pesticide has been developed. This is to ensure that these exposure routes are no longer addressed separately. The final midterm project concerns deriving new relative potency factors using new approach methodologies for substances on which hazard data for grouping is currently lacking. This project focuses on contaminants, but the principles developed here could also apply to other chemical domains. Finally, moving to long-term projects, the roadmap sets out a proposal for the use of human biomonitoring data. In recent years, there's been a marked increase in the availability of such data, and their application within the regulatory domain needs to be expanded. This project aims to develop reliable human biomonitoring biomarkers to address aggregated exposure. The project also focuses on one chemical domain, namely pesticides, but the principles applied within the project could also be used for other domains, as well as cross-silo assessment. The roadmap also proposes a project to assess the impact of coformulants on the non-dietary risk assessment of pesticides. There is a general lack of information on the toxicokinetic influences of coformulants on active substances, as well as a lack of thresholds for coformulants. This project aims at generating information on toxicokinetic influences, as well as developing a strategy for the prioritization of coformulants and for deriving thresholds for these coformulants. Once such information has been generated, non-dietary exposure models could be adapted so as to be suitable for coformulants. Stakeholder participation and engagement is essential to develop the methods, data and tools needed for MRA in the follow-up projects identified in the roadmap. The views of the stakeholders on how EFSA could engage with them were inventoried using an online survey. The majority of stakeholders felt that EFSA informed them sufficiently on MRA development, and about half the respondents to the survey felt that EFSA's collaboration with stakeholders was sufficient. Some suggestions were made to improve stakeholder engagement, such as providing a catalogue of the tools, models, method and data on mixture risk that are available or under development, as respondents felt that these were currently difficult to retrieve. Another suggestion was to organise regular workshops and seminars on the topic, so as to exchange ideas on tools and projects. In-person training on how to use MRA tools, methods and data was also put forward, as was the provision of regular updates on ongoing work, not just when the work has been completed. To identify opportunities for communicating with the general public about MRA, a questionnaire was sent to communication experts at national food and nutrition centres and at national public health institutes in Europe. One of the things that was highlighted was that communication on MRA is quite difficult, as there is a general lack of understanding of the topic. The fear was that communicating on MRA could create the image that our food isn't safe. Another point that was highlighted was that the public generally doesn't access information on food safety from EFSA's website, but rather from websites or national communication hubs in their own native language. It was therefore recommended that EFSA works jointly with national communication hubs for food safety in their strategy to communicate with the general public. For the most part, visual communication methods were recommended as communication tools. These included animations, videos, and infographics. Overall, it was concluded that concise and understandable communication is key. The roadmap was finalised in August 2022. We want to take this opportunity to thank all the stakeholders for their valuable time and input in the development of the roadmap. Their views were essential. The full roadmap is available on the EFSA website for anyone who would like to know more about the outcome of the project.